Hey, yo, 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 yo! This is Gradius coming at you live from DePaul Middle School. For the video on 1.2, we're adding integers with different signs. So let's get after it. Here we go. So we can add integers with different signs. And so before in 1.1, we were adding integers that had the same sign. Now we're adding integers that have different signs. So a couple vocabulary terms. We have sum here. We should all know what sum means, but in case we didn't, it's the total of an addition problem or the answer to an addition problem. Okay, and we also have zero pair, adding one positive integer and one negative integer. So when I have one positive integer, and I'm going to use a counter right now, or a chip, and I have one negative integer, that creates a zero pair. They cancel each other out. So one positive and one negative makes a zero pair and cancels each other out. All right, so what we're going to do is we are going to model adding numbers together that are both positive and negative, so numbers that have different signs. So we have two examples. We're going to model on a number line, and we are also going to model with counters. So first, let's look at a number line, because a number line is the exact same thing as what it was when we were adding numbers with the same sign. We always start with the first number. So I start at the first number. So for 4 plus negative 3, I'm going to start at the number 4. Which is here. And we're going to move in the direction that it tells us to based on whether or not we're adding a positive or whether or not we're adding a negative. So because I'm adding a negative, I'm going to move left on my number line. So that's going to be negative 3. So that's 1, 2, 3. So that means 4 plus negative 3 is positive 1 because I ended here at 1. So because I'm adding a negative number, I move left on the number line. When I add a positive number, I move right on the number line. Looking at negative 7 plus 5. Okay, I'm going to start with the first number on a number line. So that's negative 7. Starting at negative 7 right here. Now because I'm adding a positive, I'm going to move right, and I'm going to move that many. 1, 2, 3, 4, 5. So the answer is negative 2. Because I finished here at negative 2. Now that's how we do it on a number line. Now let's look to see how we would do it if we were using counters. So with counters, I'm just going to erase this, give us some more space. With counters, we're going to model it with using those chips. So I'm still going to represent positive 4 here. So I have 1 positive, 2 positive, 3 positive, 4. So I have my 4 positives, and I'm combining that with 3 negatives. So instead of doing it side by side, I'm actually going to do it one on top of the other, and you'll see why. 1, 2, 3. So 4 positives, 3 negatives. So what I'm going to do is I'm going to look for zero pairs that cancel each other out, because we know that a positive and a negative cancels out because it makes 0. So the reason I did it on top of one another is because this positive and this negative makes 0. Whenever we make zeros in math, it helps us cancel things out to make life a little bit easier. So this positive and negative cancels out. I have another zero pair here that cancels out. Another zero pair right here. So with all those zero pairs canceling out, I'm left with 1 remaining because I have no more negatives left, so I have nothing else I can cancel. So I have 1 positive left, so my answer is positive 1. Same thing here. If I have negative 7, so that's 7 negative chips, 4, 5, 6. So there's my negative 7. And then I'm adding 5 to that. So I'm adding a positive 5. So that would be 1, 2, 3, 4, 5. So I have negative 7 and I have positive 5. Then I'm combining all these together. Well, I don't have 12 negatives because I have some negatives and I have some positives. I don't have 12 positives because, again, negatives and positives. But I have a bunch of zero pairs here. Those cancel, 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 cancel. I'm left with negative 2, which is what we got already, because that's what's remaining when I run out of all my positives. So that's how we would model adding numbers that have different signs. Now, some of you might have already figured out a rule just by looking at a pattern here. Okay, but we have that rule right here. So the actual rule is whenever we're adding numbers with different signs, we're subtracting the lesser absolute value. So going back here, we're subtracting the lesser absolute value, and we're keeping the integer, we're keeping the sign of the integer with the greatest absolute value. So here's what I mean by that. Like, let's look at here. I have negative 7 plus 5. So really, as I'm subtracting the numbers by doing, I'm doing 7 minus 5, which is 2. I'm taking away the number with the smaller absolute value from the number with the greater absolute value. It doesn't matter which one's negative or which one's positive. I'm just taking the smaller number, subtracting it from the bigger number. And then I keep the sign of the number that has the largest absolute value. So because I have more negatives here, this is the largest absolute value, that means my final answer has to be negative. Okay? So what we're going to do is looking over here at this example. I have 3 plus negative 5. So I can't do 3 minus 5. That's what a lot of people want to do. We can't do that because we have to subtract the smaller number from the larger number, the smaller absolute value from the larger absolute value. So for this one, it'd really be 5 minus 3, which is 2. We should all know that one. Okay, and then we keep the sign of the larger number with the larger absolute value. So negative 5 has a larger absolute value than positive 3. So that means I have more negatives than I do positives, so my answer has to be negative 2. Same thing here, negative 10 plus 1. I have more negatives than positives, so my answer has to be negative. 10 minus 1 is 9. Let's do number 7 together, which is negative 51 plus 23. And then I'm going to have you try the other ones on your own. So first, I'm adding two numbers with different signs. I'm adding a negative with the positives. I don't want to draw out 51 negative counters. That's going to take us way too much time. I also don't want to do this on a number line because I don't want to move 23 places on a number line. It's going to be too long of a number line. So when I notice that I'm adding numbers that have different signs, I'm combining a negatives with positives, I know I have to subtract these two numbers. So I can always do that off to the side. I know I have to do 51 minus 23. Okay. And then so when I do that, let's do that subtraction real quick. 11 minus 3 is 8. I did my borrowing. So I get 28. Now I have to determine, is my answer positive or negative? Well, I have 51 negatives and I have 23 positives. So if I combine 51 negatives with 23 positives, I have a lot more negatives than I do positives. So that means my final answer should be negative. When all these cancel out, if I were to create my zero pairs, all these positive 23 chips would cancel out, and I would have 28 negative chips remaining. Okay. For number 8, I have 10 plus negative 18. So for 10 plus negative 18, again, I'm going to, oh, there's the bell. Let that ring. I'm going to subtract the smaller number from the bigger number. So I'm going to do 18 minus 10. I know it's set up as 10 and 8, 10 was the first number, but it doesn't matter what order I subtract in. I mean, it doesn't matter because the order I subtract in has to be the smaller number being subtracted from the larger number. And then I also have to look, is my answer going to be positive or negative? Well, my answer has to be negative because I have more negatives than positives. So my final answer will be negative 8. All right, try number 9 and 10 on your own. And then, so pause it, try those on your own, and then check back here to see if you did them correctly. So for number 9, I have 13 plus negative 13. So this one, you might see right away, well, these are the same values, they're just opposites. So this is actually going to create 13 zero pairs, so the answer is just 0. When I combine a positive number with its opposite, with its additive inverse, or with the opposite version of it, it's always going to give me 0. Okay, I can also look at it like, well, I got to subtract the numbers. It doesn't matter which order you subtract them in because they're the same value, and you get 0. Okay, for number 10, 25 plus negative 26. So with 25 plus negative 26, I have 25 positives, 26 negatives. So I have more negatives than I do positives, and so I know my answer has to be negative. Now I just got to subtract them to figure out what the difference between the two are and how many negatives I have left, and it's just 1. So my final answer was negative 1. And that's it. So jot down some things to remember. An abbreviation, this is kind of combining all of, and I'll actually type this up to make it a little bit easier for you guys. So an abbreviation here for the rules for all of adding integers, whether they're positive or negative, or whether they're the same sign or different signs. So my abbreviation is same sign, keep and add. Different signs, subtract, and keep the sign of the bigger number. Let me make this smaller for you guys. So whenever we're adding two numbers with the same sign, we're going to keep that sign, and then we're just going to add the numbers together. That's what we did in 1.1. Okay, so that's going more for the example. Same sign, keep and add is really for the example of like negative 5 plus negative 6, which gives me same signs, keep that sign, add them together, that gives me negative 11. Different signs, so that's what we were just working on. If I'm adding two numbers with different signs, let's add 7 plus negative 9. I'm going to subtract the numbers, so I'll do 9 minus 7, which is 2. And then I'm going to keep the sign of the bigger number. 9 is bigger than 7, so I have more negatives, so my answer is negative 2. So these are just, this is a quick abbreviation of both rules to show whenever we're adding integers, if we add them or if we subtract them, and how we determine if it's positive or negative. If you have any questions, please jot those down. I hope this video was helpful and we'll get some practice in. Thank you for watching, guys. Gradius out.